Next, we'll deep dive into bivariant analysis. Here I have bunch of methods. We will see one by one. Prepared from the data frame. Here I am taking data frame as an input, and target variable is the loan status, which is a binary variable, whether the loan is approved or not. First, I am converting all the numerical columns, categorical columns into numerical, and I'm dropping off the targeted variables, and I'm using the min max scalar. The reason for that is the machine learning algorithm should not give more importance to the higher values. So that's why we are using min max scalar to standardize the value. And I'm returning back x scaled y. And we have the point bicellular analysis. Here we are taking data frame and the target feature variable and all the numerical column. Basically, this function can be used only by the numerical column. Here we are trying to understand for all the numerical column, what kind of relationship does it have with the targeted variable, which is the loan status. We are trying to do it. Basically, we have been calculating the p-value. If the p-value is less than 0.05 means it starts from 0 to 1. Whichever the p-value has the higher value, that means that has a strong relationship between the targeted variable. Okay, and move on to the categorical analysis. Here, this method can be used for to know the relationship between the categorical columns versus the targeted variable. Here we are taking data frame, loan status, and all the categorical features column. Here I used CS2 and the cramps function. Base, if the values are higher, then that feature contribute more towards the model performance. So whoever has the higher value among the feature, that contributes more towards the model performance. In other words, too, we can interpret whichever has the higher value, that feature contributes more for the loan approval. Okay, fine. Let me move on to the approval rate by feature. Here, this one can be used if you wanted to know the relationship between the targeted variable versus the any categorical column for any by grouping the people. Let's say we have the living area. It's an urban, semi-urban something. If you wanted to know like which living area has an higher rate of approval chance, here we can use this one. And this next one is the approval summary. So here also it's doing the same thing. Okay, so I have two methods. One is approval rate by feature and the approval summary. Okay, next one is the draw business insight. This one is to draw a different chart. I have written this method. Okay, now let's go into the Jupyter notebook. We will see one by one. So here I am calling the point bicellular. Here this is for all the numerical column. It has a higher value. So as I mentioned, like if it is having higher value means this feature doesn't contribute much towards the model performance. Next one is the categorical features, categorical columns. Okay, here you can see the CR score is high for the credit history. That means which is a important and the strongest driver for the model performance. In other words, too, we can interpret that way is whoever has a good credit history, the credit history has 0 and 1 value. Whoever has a good history, the chances are high for their approval. Okay. And next one is approval rate by Mendar. So here I am using approval rate by feature. So basically I'm trying to understand between male and female, whoever got the highest approval. So here you can see who the male applicants has a higher chance for the approval. They got approved 69% and the female applicants got approval of 66%. and the credit history. Okay, whoever has a credit history of 1.0, they have the higher chance for the approval. They have 79 percentage, and the credit history of whoever has the credit history of 0, they have the approval percentages of 7. Okay. And here I'm using, I wanted to know what is the loan approval percentage by the living area or the property area. So here I'm using NumB functions to categorize the column. And once I have categorized the column, I using the approval summary, I'm just calculating what is that approval percentage and draw the business insight. As I mentioned, this method can be used to draw a different charts. Here you can see in the x-axis we can see the credit history, and in the y-axis we can see the approval percentage. So whoever got 0.0 percentage credit history, their approval rate is very slim. They got approval around 8 to 10 percentage. Whoever has a credit score of 1.0, their approval rate is high. You can see it's an 80.0. That you are seeing the middle one line, right? This is an error bar, which means that it's a speculation. It's not the final output. Okay, it's a speculation. Okay. And next one is the loan approval by property area. Here we have urban, rural, and semi-urban. The approval, whoever lives in a semi-urban area, they have higher chance for the loan approval. And next one is the loan approved by the applicant income. So here basically the distribution for the applicant income is range between 0 to around 70, and the data spread is more for around 10,000, right? The data spread is more. That's it. And for the rejection, that starts from 0 to 80. That's it. And loan approval by gender, like here also we can see the male dominates, but we don't see much difference between male and the female. Okay, and the loan amount distribution versus approved and the reject. So here you can see the whoever has the lower amount, right? Their chances for the loan approval is very high, and whoever has requested for asked for more loan amount, their approval chances are slim. This is called a bell curve. Here you can see the data spread. Okay, here you can also interpret like whoever in between the range of 100 to 90 to 200 150, the range is more. So range is more. I mean, whoever has a loan applied for the loan, right? The loan amount average as in between, it's between 100 to 90 to 150. Thank you.